Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say, no good deed goes unpunished.
Good morning, Vietnam. Yowza, yowza, yowza. Couldn't resist it. Sorry. Anyway, what are we doing today? Why have I played the longer intro again? Well, the short intro cut me to the quick. Couldn't quite transfer over and back again before it finished. So unfortunately, it is what it is. Anyway, so the short one didn't work out too well. Anyway, so what have we got to do today? We haven't got long to do anything, about an hour. So I've got to change the holes I put in for the base for brass inserts. So, because imagine if you're up trying to mount it and work on it, you don't want little nuts falling down on the floor, you're trying to work on it. So let's just get on with it, and I will show you what I've been doing on the other one. I built some parts on it as per all this here. I'll give you a quick look at the physical. All this here. Okay, here it is. There it is. Remember, this is just a prototype. It's the prototype, and it's not perfect. As in, that cable comes out for the sensor. The sensor's inside there. Let me just see if I can withdraw the. Yep, I can withdraw it. I can't get it out because. Hang on, might be able to get it out if I just lift it out. Yeah, just about get it out. So there's your PCB, and your magnet is in the red bit. The magnet spins round this IC. This IC gives you angles 0 to 360, and you read it via I2C off this cable. Just put the little cover back on. So just about get it to go with the flex in the natural flex in it. Yeah, that's clicked in place. So anyway, you've got that. So the problem is now, because this is an axle bearing, and I've put an axle bearing here. Now the belt is pulling on it. You've got the pulley wheel pulling on this that way. It just feels a bit weird when you turn it. In reality, it'll be turned from this wheel here. So it's okay, but I've put no grease or anything in it. But it's pushing. It is an axle bearing and not a thrust bearing. So maybe we'll have to modify that. Anyway, so at the minute, my model shows a wire hole coming through there, which means the cable will have to go between the belt. We don't want that. So it needs to be routed up this way, like that. So we need some retaining clips and a hole in this corner. Then we need to get rid of these holes here. These holes. Or put on the back a brass insert instead of just a hole. So then we can mount all the other bits with these fixings, like this, without having to worry about the nut falling down and losing it. So anyway, that's where we got to. We've only got an hour probably. I think after we're going to have to put a shroud on it here. Once this cover's on, we're going to have to put a clip-on cover here, dust shield, just to keep everything out. So we've got a bit to do to it. Anyway, let's get on with it. Let's get on with it. Right. So number 11, base brass inserts into these holes and reroute this cable. Okay. Alright, let me just bring that over here. So you can see I went ahead and made a hole there for the cable, but that's between the pulley cable. That was a bit of a silly thing to do. So we need to hide this as well. Well, that's still part of a different model. It hasn't got a... We haven't given it anything. We need to put it onto a different plane. So let's group that. We won't make it into a component. Oh, we will. Go on then. We're going to give it a... Right, it's the... we'll call it a dust cover. Bottom. So we'll call it the stepper dust bottom dust cover. That's what it's going to be. Bottom. Where has it gone? Let's not put it there. Oh, it's called stepper bottom. Yeah, we need to put a hyphen in that. So we're just going to put a hyphen in that. That's it. Okay, so we've got it there, so we can turn it off. That's it, so we can just work on this bit. Yeah, so it's not going to be much of a stream today, just a bit. Right, so yeah, I need to turn this into a brass insert. Now it's a sideways one. Right, so we're going to have to do a bit of work on it, so let's go into this. Right, so all we want, instead of having a hole and having to have a nut on the back, we want a... we need the hole still, but we need the receptacle part to put the brass insert in. So let's just do that now. What's it doing? Why is it not doing that? That's weird, isn't it? Okay. Right. So we know we want it needs to be about 6 mil. Let's say 7 mil. We can always change it, so 3.5 mil. Then we want a one at 2.325, I think it is. 2.325. And is that 4.65? No. Undo that one then. So it's 2.235. Now, is that for 4.65? No. Too big. I can never remember that one. Alright, let's go again. So 2.325. Nah. Hang on. I'm going to have to work it out again. I need to write this down. I keep telling myself that. So it's 4.65 divided by 2. 2.325. Doesn't help being dyslexic. 2.325. I should write that down on a little help it note somewhere. 2.325. Right, okay, let's try again. 2.325. I thought I did that last time. That's it. That's what we want. So what we've got to do now is got to bring the plastic up 5mm. Now the brass insert has to be fitted from the other side, melted in, so we're going to have to, yeah, push that through to there. Then we're going to have to put our brass insert in. We need a base to it, so we're going to have to lose that, go around and lose the other one. Oh, we've just took a, hang on, let's undo. We can't have our base, so I'm doing it from the wrong side basically. Let's do it now. So 2.325, and then we want 3.5. So we should have 6. Sorry, for an M3 brass insert, you want 4.60, and they need a wall thickness to be able to push it in. Right, so let's do that. So I need to go around the back of this. I need to withdraw that, take that off there. Let's just have a look at it in 3D. Sort of like it, isn't it? Sort of. Now the small inner hole needs to go. So I need to push that through to there. Sort of. Yeah, I don't need this outer layer here. Right, okay. So that's the, not gonna fit it. Oh, that's the inner bit. Yeah, that's right. That's the, trying to get on top of it so I can deal with it better. Right, so we should have 4.65 there. That's the plastic there. Now we need to delete the hole we've already got in it. How do we do that? There's no surface there, so we need to delete that. Probably delete that or cut that off. Paste it in place. And cut it and then go back into it if we can. Not from that angle, we're not. So go back into this, paste it in place, and we should be able to push it down. It should have become part of this, yeah. So now we need to go down 5mm. That's the height of the brass insert. So we've got the brass insert because we're going to include the thickness of the material as part of the depth. And we've got too much depth here now because we don't need all that much depth. So we'll come around the other side. We don't need that much depth. So let's see how much depth we've got. 2.5. We only need about 1mm basically. So, well, easiest way is just to bring that down 1.5mm. Is that enough? Let's try that. Still a bit too much really. Or we could just have it so it pushes in. Yeah, so they can put a longer bit through it. Yeah, we could have it hollowed out actually. You could put longer screws in instead of having to have the correct screw. Yeah, might help, that might. So, in that case... we need a shoulder, yeah. I know what to do. So we need a shoulder. So we'll have that, but we'll have a shoulder. Because at the minute we've got the room for the brass insert. But what we want here is just the room for the 1.6. Right, so what this will do is it'll allow us to push a hole through. That's it. So you've got a shoulder for your brass insert to stop at 5mm. So let's have a look. Yeah, 5mm. Then you've got 1.5mm of shoulder, and you've got some material around it, and then you've got a screw can come all the way out through the back of the insert, so you don't have to be restricted to the size of the screw. Now we're going to be printing it like this, so we need to be able to print it the other way. So we need some support material. Now we can either support the whole thing, it's going to print it straight up, we can either come straight down. Let's just do that. So we'll just come down, straight down to the floor, and there, that's it. And once we've got this, we'll copy it to all the rest. There we go. So we've got the solid bit, we need to get rid of this bit. Yeah, and what else do we need to get rid of? Yeah, we don't. Oh, that doesn't need to be there either. That bit. Right, so what have we got now? We should have just, yeah, just what we want. We've got a bit of a weirdness going on here. Hang on. Right, so I need to draw a line there a second. And reverse the face. Oh, just delete. No. That's weird, isn't it? Okay, so undo, draw a line. So we just want to colour this. I don't know why it hasn't picked the colour up from the rest of it. Anyway, so we're okay there. We've got our stud. Now, is it too thick? No, I think it's okay. Right, because we're going to print this flat down to the deck. Now that's okay. So we want to reproduce that now all the way around to all the other fixings. So let's try and do that. Let's go on X-ray mode. Let's try to grab this as much as we can. Exactly what we want. So we're going to copy it. We'll paste it in place. And we'll have to move it. So we'll move it by this. Okay, and we're going to put one over here. Is that the place? Certainly is the place. So we're going to put it there, but we'll leave it there for a second because I've got to go into this, delete the original geometry, come back out, then grab this new bit and cut it. Oh. Didn't I just get rid of that? Oh no, that's the outer bit. Which one have I just got rid of? I've just got rid of the wrong one. Right, do some undoing. Undo cut. Undo close. Undo erase. Yeah, I selected the wrong bit. I need to just select that bit there. So, let's get rid of that. Come back out. Now grab the bit that we want. Then cut it. And I've got to get back to the bit we're after. Paste it in place. Okay, so far so good. Yeah, is that good enough? Don't know. Let's try it. No. Oh, maybe. Hang on. No, we need to integrate the faces with the model. Alright, let's just see if we can integrate the faces with the model. Intersect, sorry. So that should be, what's the name now? Is it rect anything else? No, I don't think it's rect anything else, is it? Let's just have a look in normal mode. So I should be able to delete. Oh, hang on. Why has it put a? It's put a weird size thing there. That's the inner bit. So let's just delete that. Oh, what's it done? It's done some interfacing with the model. Yeah, sometimes it's easy just to start again and do all your own geometry. If you try and intersect it, it creates all this geometry, cause you more trouble. But yeah, we could do that. But anyway, let's just do this one. Right, so we've got that there. Now we should be able to get rid of that. Should be able to be gone. Oh, shit, hang on. Right, so what have we got? We've got a similar thing now there. I don't know. Let's have a look. Is that a hollow? No, I think that's it. Yeah, I think we're okay. Does look weird though. Yeah, we've got a bit in there, and we've got some extra geometry. Look, this is what happens if you do it this way. That's what happens if you do it this way. We end up with too much geometry. So, oh, now we've got to get rid of this. Yeah, I think I'll do it the manual way instead of trying to copy it. Because when you intersect it, it gets confused and it starts adding stuff that you didn't want. It's just a program, an algorithm at the end of the day, doing what it's told to do. Anyway, so does that give us what we're after? It basically does, yeah. So we've got two holes there. Just make sure, and we've got some support on the back. Yeah, for the brass inserts. So I suppose we could put brass inserts in a minute. And do they line up with the original hole? Yes, they do. That's fine. Yeah. Okay, so we've done 2. I think we're going to do the rest manually. So when I say manually, not quite manually. So what I'll do is I'll grab that, not that. I'll grab the framework. We'll copy that. Okay. I've got 2 holes this side, whether they're straight lined up holes. They might be. Well, let's just do them 2 first. Right. Let's paste. Oh, so we're going to paste it there. We need to grab it from the center. Right, and we need to then line it up with the center of this, which is that. That's one. Then we need to copy it again over here. This is gonna speed things up again. Right, that's okay. So I'll do all this first. And then we'll just copy it. We need to spin it round. And then bring it back over here. That's it. And copy it again. You have to press Control in when you want to copy it. Another one there. So then we want to grab this one and then bring it over to the other side. So if we just do a copy again, and will it go there? Have I made the holes yet? Oh, almost. One hole's not quite right. I must have had to space it around because of this lug, yeah. So we'll have to... I think that's buggered it up now, yeah. I'll have to cut that one off. Can I cut that one off? Yeah, so I'll have to undo, copy, grab just this one, copy that, I'll just copy the single one over for there, and then we'll have to manually copy this one and then push that wherever this one needs to be. That's it. So have we got, we've got all the areas. See what this has done as well. Look, that's intersect the faces, has created this extra line and some weirdness over here. That's probably the way I've selected it. Make sure there's nothing else. There's another weirdness. Probably some and here. Yeah, so that's what happens when you intersect. It goes a bit crazy and it thinks, and it leaves you to manually sort stuff out, and it's gone and put all the lines in here, so I'd have to just go over it and smooth it. Get rid of those lines. Has it got rid of it? Yeah, just got rid of them for me. Right. Okay. So we're back sort of, I think, to where we left off. We seem to have too much going on here. Look what it's done here. Look at the intersects done. Can I get rid of that? Or is it going to ruin it? No, it's going to ruin it. Yeah, this is what's done, intersect. Shit. So Tell you what. How far can I go back? To that initial intersect over here, wasn't it? Right, let's go back. Let's go back. Keep going back because I don't want to be spending hours bringing back all that stuff. So I'm just undoing a lot of the stuff till we get back to the is that the end of it? Am I at the end of the undo? No, I'm not. Why is it? Oh, still undoing. Have I got to the end now? No. Well, I have no idea what's going on now. It seems to have stopped undoing. Still got some undoing to do. It must have been the intersect. Yeah, the intersect, that's it. So we've got past the intersect. Well, we've now deleted the hole. Right, want the hole back, so we've got to the point where we want the hole back. Let's just make sure we've got, yeah, we've got the original hole there as well. We didn't. Okay, so we've got that there. We need to get rid of that. Just delete that off there. We don't want it. We don't want it. And we just want a copy of this again. Right, so we'll get a copy of that. And we'll grab it from there and position it. Oh, what has it got? Hang on. Must have the field with it. Why has it got the field with it? Undo copy. So we want that. No. Tell you what, we'll just grab that, that, and that. And we'll copy that. We'll put that on here. Like that. And we'll do the rest. Let's go around and we can, yeah, you have to do certain things in a certain way, otherwise you end up with more work later on. We don't want more work, we want less work. So in the future, AI is going to take over what you're doing if you're working in a new environment. It's going to say, it's going to be like somebody, a helper or a colleague that's with you, who constantly wants to take over your work. It's gonna say, let me do that, I can do that quicker. And it's gonna take over and do all the work for you. And you're just gonna sit there with your hands folded. You can go and make a cup of tea. So, I need to copy that out over here. Spin it round like that, and grab it and push it over here, and grab another one for this one over here. Right, and then we want a copy of that one. There, I believe that's the right place, yeah. Then we want another one which won't be the right place. So we'll have to grab a copy of this, push it over here. Yeah, there's a revolt against AI. Because basically it can do everything, or it thinks it can. At the minute it makes a mess of stuff a lot. But it'll be trying to help you. It'll be like a colleague trying to take over what you're doing. Let me do that, I can do that quicker. And it does it, but it's not your interpretation, it's their interpretation. So it ends up being, it's not your work, it's their work. It's not your idea, it's just... Anyway. So, do you want to relinquish control? That's the thing. 4 mil. So, all I've got to do is go around here and bring that out 4 mil. 4 mil. And the rest of it. 4 mil. See, it's already got an extra line on it, look. We'll get rid of them in a minute. Smooth it out and all them will disappear, maybe. 4 mil. 4 mil. Nearly finished, not quite. Oh, one more. 4 mil. Now that gives us our standard size for the screw. The thread, yeah, plenty of room for the thread, but it doesn't give us our inset. So we want the size now to go over it, which is 2.325 radius. So we've got to go over here, put in another circle. 2.325. Okay, no, that's not it. Oh, is that in the model? Maybe it is. Yeah. So we do that, and we've just got to push that in. It's just got to go in 5 millimeters. 5 millimeters, and it should give us 1.5 mil of plastic shoulder. Yeah. Okay, so that was easy. And the same again here. 2.325, if I remembered it right. Yeah, and then push that in 5 mil. And there's more to it. And you can put a little bit of a lip on it so it helps you push it in. Yeah, I think I'll do that as well in a minute. I'll put a bevel on it. .325 5 mil. .325 5 mil. It means we're going to use some brass inserts, but you know, it's about 8 of them. It all costs money, but a nut's probably cheaper, but it's more fiddly. And if you're up a ladder trying to mount this thing with the cover off, the last thing you want is to drop your nuts into the grass. 2.325. So at least the brass insert will be melted in, it won't come adrift. And if you drop the screw side of it, well, I can't help that. Use a magnetic screwdriver or something. Okay. A few more. See, it won't let me. 2.325. 0.5 mil. Right, so have we finished? Yeah, we've finished, but we haven't got a bevel. Do we need the bevel? I don't know if we need the bevel. Might not need the bevel. And it wouldn't lend itself to creating a bevel very nicely when you're printing it this way up anyway. So we'll leave it at that. Let's just smooth it all out. Okay, so we've got that. So I suppose we better put some brass inserts on it. Yeah, so this base is what attaches everything around it. Yeah, so the cover gets attached through there as well. Right, back in a second. Alright, back. Okay, so brass inserts next. Need to find a brass insert. Where have we used one? We've used one on the end of this shaft somewhere. No, can't see it. Have I got... Oh, I haven't actually put that on a layer, have I? I need that on a layer. So this one's going to be the magnet. Did I not call this? Rotator, encoder PCB. Right, so I didn't call it anything. PCB cover, encoder PCB. Right, okay. Encoder. Magnet retainer. Okay, so that's the magnet retainer. Encoder, magnet retainer, and then we've got the encoder magnet. That's a retainer clip. So they got the magnet push on, for lack of anything else to call it. Encoder, push magnet, push on. Apart from I've spelt it wrong. No, I haven't. Magnet. Why did that look weird? Oh, I did spell it wrong. magnet. Oh, got the two characters round the wrong way. Right, okay, so now I can hide those two. And I can actually grab the screw and the fixing all in one. I'll copy them out. Gotta reuse them over here. No, I don't want them in the model particularly, so I want to paste them. We're going to rotate it. Let's rotate it around that axis. Like that. And we've got to put that. Easier said than done. What about from the back? Will that be easier from the back? Not sure. Might be. So we're going to grab that there and put that. Oh, we're going to need X-ray mode for this. So we're there, but we've got to go. Oh no, we're not there. We're not there. Are we there now? Yeah, we're there now, but we're too far down. So we've got to go back in by... Who knows? Oh, that's the screw. Right. Oh yeah, so it's just got to go into something like that. Yeah, that's okay. The screw's in the wrong place by the looks of it. Yeah, it is. It's thicker on this one. So I need to grab just the screw and bring it out. And then drop it to the surface. Is that the surface? Yeah, it is. Okay, so now I can grab both of those. No. Yeah. I can grab both of those now. I've already got the screw, so I need now the brass insert and group it. No, not that one. Group it. We need to copy it. How do we copy it? I can copy it by knowing the size between the two. So if I measure from the center of this or the edge of that to the edge of this one, 99.445. So all I've got to do is come out of there, grab that, copy it, and move it 99.445, if I remember right. Did I remember right? Yeah. Okay, so we've got those two there, and we're going to need... These are actually longer because they go all the way through. It's the same brass insert. So... And they're not in the same position. One of them is, one of them isn't. This one is. So if I can measure from where is it? Oh, it's got to go to the outer cover, that one, isn't it? Right. It's more complicated than it seems. So what we'll do is we'll just copy that. paste over here. I have to do it manually. Let's rotate it around the blue like that, and somehow make it fit. X-ray mode. So we need to grab it by the center if we can. The center of, hang on, right, let's grab it by the center of this here. Well, the part of the model behind it's getting in the way. That's it, that's where we grab it from. Now we've got to go here and somehow line it up with this centre now, because we're seeing too much other geometry. So move it to a position where there's no more geometry, so we can get it to line up. Yeah, that's already lined up, and all we've got to do now is measure from there to there, 50.50. So just grab that, copy it, control, and then it's just type 50.5, and there we go, we got that one done. And these two are the same. So if I grab, tell you what I'll do, if I measure from there to there, 132 mil. If I grab two of them, copy them, 132 mil, then flip them, flip along, I don't know which axis.
Morning, matey. How you doing? I'm fine. 400.
Flip along the green. No, I was right. Flip along the red, and then I've just got to push them in from there into on the face of the component, and that's those two sorted. Now it's just these two at the back, so we can work out the size, but we've got an extra layer here. So can I turn that bracket off? PCB bottom cover, PCB mount, no. Stepper cover, no. I don't know if I'll give that a name. Have I give that a name? Bottom cover, PCB mount, yeah. So turn that off, so I can get to the bolts to grab them again once I've copied them. So we need to move that from there to, hang on, let's find something with some material on it. 83 mil. So we'll copy that, 83 mil, and then we've got to flip them along some axis, don't know which axis. Flip along, let's say the green, yeah, green axis. So one of these will be lined up, one won't. So let's just push that, both of them, from there into the surface. I think that's okay. Yeah, that's it. So that can stay there. This one will be wrong because it needs to go over a bit. So we need to grab this center of this bottom, which is there. I need to line it up with there. Okay, now it's not the end still because the fixings have got to be moved. That's got to be moved, and it's too short, but we won't bother about that. We'll just bring it back 2.5 mil. And then this one, hopefully the rest have stayed where they are. Yeah, that's good. And this one needs to be brought back 2.5 mil. There we go. Right, so I should be able to bring the cover back on now. Come out of X-ray mode, and we should be lined up. So, oh, what's happened to the brass insert there? Ah, I didn't move that one nicely. Right, let's do some undoing. Right, I must have had them both selected. Right, I had them both selected when I moved the one. Right, let's go and move that one over the right hole again, like we just did, but only with that one selected. Right, that's it. All lined up now, yeah. Okay. Just need to bring that out 2.5 mil. Okay, put the cover back. It's not the one. There it is. Okay, so we've got the screws, the brass inserts, yeah, and yeah, everything's there. Now this hole, I put this here to pass through the cable. Let's come up the right way around. And we can put the PCB, that's the retainer, that bolts onto there as a way of clipping the magnet push on over it. That holds the magnet. If we look in 3D, you'll see the magnet there. Oh, so where is the magnet? Don't know if I've called the magnet anything. Hang on. Right, no, I haven't given that a encoder magnet. So I need another layer for encoder and the magnet. So we'll put that as encoder magnet. That's it, so we can turn magnet on and off. Right, so that magnet, the magnet pushes into here. It's a tight fit, you can glue it if you want. Now what would be nice if there was a hole in the bottom of this to be able to push the magnet out if I've got it in upside down. I don't know which way it's supposed to go. It might not matter, but it might do. So if I could just have a hole in the bottom of this plastic, I've already printed it, but next time, just so you can poke the magnet back out again, that would be nice. So let's put a hole in. How big does the hole need to be? Not very big. I don't know. 1 mil, 2 mil. Diameter. Let's say it's 2 mil diameter. So 1 mil radius. I don't know how thick it is. Can't remember how thick I made it. Oh, it's just to the thickness of this. So I can measure it, I suppose. .6 mil, it's only thin. So if I push that down, that's it. That's it, so I've got a hole through it. So you can push the magnet in, but then you can poke it back out. You'll have a hole that you can push something that's 2 millimeter diameter or less to push the magnet out if it's the wrong way around. So if we come out of that, you should be able to see the magnet. Yeah, it's a tight fit. You can hardly push it in, so which is good, which means you might not need to glue it. Okay, so that worked out pretty well. Designing that took a while on one of the streams to get these to spring and clip over the... You can't see it now. So they clip over this other bit here. So that prong, sprung loaded clip fits over the ridge here. And there's enough receptacle area for the nylon or metal screw to go, depends on what you're using. I think I used a nylon just to keep any metal clear of the magnet. And then you've got your PCB, which is inside this cover. So bottom cover PCB mount, no. There's one called bottom cover, PCB cover, is that the one? Yeah. So there's the plastic cover that slides on. Got a couple of brass things there. There's your chip. This has to spin around the chip within a certain amount of gap, so I've allowed for play in the shaft here to drop on it. So hopefully once the weight's on it should still be clear. I've got to shore up this bearing. There's a bit of play in it. I knew about the play, but I left it, but I could do with getting rid of the play, some of it, because of this now is on the end of the shaft. Right, so the cable from the PCB goes round here, out this hole. Now initially I set it to come straight up into here, but I forgot about the belt. I don't want to be passing the cable through the belt, so it's now going to come across here and up into there. So somehow it's got to have a retaining clip, or we just come straight out the bottom. So let's take the cover off a minute. Oh, we better save this. Better save that. Right. Yeah, this Rotator series, not many people are interested in it compared to the switcher. But this is going to be in parallel with the switcher, because the same controller. Let's take the cover off. Stepper cover. Turn that off a minute. So this controller here is the same one that operates the stepper motor. This is your web interface. So in order to develop the software for the stepper, the firmware, which is going to do firmware for the stepper and firmware for the antenna rotator on a separate page, web interface. You go to one page and then you go to the next to operate the different things. So that firmware has got to be developed because it's doing the both. So I need both gadgets ready. The stepper motor's ready. Sorry, the switcher, antenna switcher is ready for the next stage, which is the software and the driver circuit. So we need to develop a little box, a little PCB here to drive 2. I'd like it to have the facility for 3, but I think we can only do 2. 2 stepper motors, so one to operate this stepper motor and one to come out of here with a cable to go over to the switcher side of it, the antenna switcher stepper motor. But it's the same software or firmware in this that operates both, so you don't have to duplicate this. You just come out off your stepper motor driver, push a cable from off this expansion port here that goes over to into your stepper motor that supplies power and everything else. Now your encoder plugs into the I2C over here. Yeah, and plug that PCB is not quite lined up right. Alright. Alright, I'll get ready, yeah. So we're going out in a minute. That plugs into there, I2C. And then your stepper motor plugs into this board, and your output to your other stepper motor goes out of here and into the stepper motor for the antenna switcher. And you run your cables, probably run all your cables to here. Yeah, you run all your cables to here. And if you don't want an antenna rotator, and you don't want the switch, you just don't reuse the appropriate output. And when you run the software, it'll ask you, have you got a rotator? Have you got an antenna switcher? And if you answer yes or no, it will hide that particular page or show it you. Maybe it'll inspire to do the other one. Right, so yeah, so all we've got to do on this is move that hole over here, and it's got to appear underneath. So tell you what I'll do, let's just get rid of that hole altogether. Going to need some cable holes as well for the cables to come through, and they've got to come through the bottom, so we're going to have to sort them out as well. Now I need to put work out, so yeah, so I need some cable gland holes really. Now are they going to come up this side and come through? Actually, there's your your brackets this side, so ideally the cable would want to come up this side. So I'd have to put some holes in here, and I've done some holes already. So you put your cable compression gland in there. Right, so at the minute I need the cable to come up into there from this sensor. So what I'll do is I'll line it up. The easiest way is to go into this cover and just grab this, measure between there and there, 13 mil. So we'll copy that out of there, paste it in place, we'll drop it down to the deck there, and that shows us where the hole needs to come up. We need a cable to come from there, and it needs to be 13mm, so we know 13mm is a good size, so we need to copy that, move it 13mm, draw excuse me, draw a little box, and then grab that. We don't need that, do we? Grab that, cut it, paste it in place. Just need to push it through now. Alright, okay. So that is our push through for this cable that plugs into there, which is the same as the thumbnail. This cable, you can't see it. Right, I'll show you on the real thing. Right, so there's that clip, comes out of there. It's got to go up into the hole, up into this hole here, which we haven't got on this version, out of here and plug into the controller, which I haven't got on there yet. Okay, right, so we've got the hole in the right place, but what we could do with is working out how many gland holes we need. So it's got to come this side underneath on this plate. So it could come through the side, but it's better if it's underneath for the weather. Yeah. Right, so we're going to use 20mm gland holes, or we're going to use 16. Tell you what, we're tight for space, let's use 16. So let's just work out where we're going to have them. Right, I suppose we could turn it round and do it. Yeah, let's turn it round and do it. We can work out where they're going to go. How many do we need? We want... all that's coming in there is the 12 volts. 12 volt supply on 2 core. This is wirelessly connected to your Wi-Fi or directly as an access point. That's all we need here. The coax comes to the outside, so all we need is the power, just the 12 volt cable, isn't it? Is that it? Oh, another output to output the stepper motor 4-core wiring to the switcher. So 2 holes we need, and there's no coax coming into here. Yeah, two little 16mm holes. So we know that's the start of. We could do with them out here, but yeah, they might be inset slightly. Yeah, we'll do that. So we'll just bring them out. Let's say need to be out enough, so that's 8mm or 16mm. So let's say 14mm. 14mm. Then we'll just come halfway, and we'll go another 14mm this way, and another 14mm that way. Then we'll put in 8mm, needs to have a slight bit of clearance. 16mm, so let's say 8.25 and 8.25, and that should give us just over 16mm. Yeah, a little bit of clearance. Right, and there should be enough room for the nut. Should be. Should there be? Yeah. Should be enough room for the nut. and because I'm not that sure, I think I'll move that over by 1 mil. Should do it. 2 mil, and then we'll move this one over by 2 mil. Okay, that's where they're going to be. Oh, let's just cut these off, paste them in place, so we should be able to push them through. Now these aren't optional. One will be optional. One needs to be knocked out, and the other one you might not want to step a motor output. So let's try and work out which one. So the one we definitely need the 12 volt. I think we definitely need this one in the corner, and this one is optional, maybe. So let's do that. Let's measure this. 5 mil. So what I'll do is I'll push this one down. Let's push this one down 3.25 mil. Right now. Right, so let's copy that. Let's move that down. Hang on. Move that down 5 mil. Turn it round. So we're on top. We need to knock that down. Let's say 1 mil. And what does that give us? Something to knock out. That's a problem because we'd have to have an infill then. So yeah, we'll do it another way. Yeah, we won't do it that way. Undo, push, pull. So I'll tell you what, I'll have a little indent. We'll come in about 0.5 mil, and we'll push that down 0.5 mil, and we'll make this thinner so you can knock it out. That's 1.25 mil. It's a bit thick, so we'll come down another 0.5 mil. What does that give us? So a little bit of a knockout. Can you knock it out if it's... There you go, you can't see it. 0.75. 0.75, so it's yeah, I'll leave it at 0.75. Okay, so then you can see it. So you can see it there. It hasn't filled it in all the way like that. So you can, I suppose we'll help it a bit by coming in 0.5 mil, and we'll just drop that down a little bit just so you can see it, and it'll drop down 0.25. That'll do. 0.25, so you've got a bit of a thing there going on, and you've got a ridge there to show you where to drill or knock out. It can just do that on the overhang 0.5 mil, and let's see X-ray, how much material is there. Difficult to see. You've got half a mil, but you've got slightly thicker in the middle. Right, that'll do. Okay, that's fine. Yeah, so you've got your motor cable, well, your sensor cable, your power, your 2-core cable for your power, and then your output, optional knockout for running the antenna switcher. Okay, that's it then, I think. We got enough clearance for the nut. So the compression gland will be down below. Don't know if I've drawn a compression gland before. I'll have to probably have to model one of those just to show it in the system, even though we'll probably just buy one. But you can print them out as well. I think I'll print them out. You can print them out now. You probably won't have the nice rubber seal though. Okay. So, is that it? Is that it? Gotta go shopping. Let's come up the right way around. So I've made this little dummy aerial. Where is it? I've made this dummy little piece of thin plastic just to put on top so we can watch it rotating. I could screw that on there, but it'll just get in the way at the minute. I could screw that on there, then you could just twist it and you can see what's going on, basically. Yeah. So I've put the brass inserts in the top of there, ready just to bolt that on. Right, anyway, let's have a look. Is that ready to print? Should I print that? Could start that printing or just print it later. I think I'll print it later on when I get back. Yeah. Now I'm just wondering if there's any need to make this tensionable. If I was to elongate, yeah, I think we'll elongate that hole. Maybe elongate these just a tiny bit. It takes a 300mm belt, and as it happens, it's okay. It's okay. Let me see some dust covers. Anyway, let's see if we've done what we said we were going to do on the. Did we do what we said? What the thumbnail said? Yeah, we did that and a bit more. We did the gland holes and stuff. Well, that's going to be it for now. Maybe later on some more. Bye for now. Thanks for watching. I'm out of here. Ta-ra.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.